Understand the three-step thermodynamic model for dissolution. The dissolution of an ionic solute, like NaCl, in a polar solvent, like H2O, can be broken down into three distinct steps. Step 1. Separating, breaking, solvent-solvent molecular interactions. Step 2. Separating, breaking, solute-solute ionic interactions. Step 3. Allowing the separated solute particles and solvent molecules to come together and form new solute-solvent interactions, hydration. Analyze the thermodynamic signs for breaking solvent-solvent interactions. Step 1. Enthalpy. Delta H degrees hydrogen bonds between water molecules must be broken to create space for the incoming ions. Because breaking intermolecular forces always requires an input of energy, endothermic, delta H degrees is positive, plus symbol. Entropy, delta S degrees, separating water molecules from their highly ordered, cohesive liquid network increases their spatial freedom and molecular disorder. So delta S degrees is positive, plus symbol. Analyze the thermodynamic signs for breaking solute-solute interactions. Step 2. Enthalpy, delta H degrees. The strong electrostatic ionic bonds holding the Na to the power plus and Cl to the power negative ions together in the rigid crystal lattice must be broken. This is the lattice energy. Because disrupting these stable bonds requires an input of energy, delta H degrees is positive, plus. Entropy, delta S degrees, dismantling a highly ordered, rigid three-dimensional crystal lattice into individual mobile ions significantly increases the freedom of motion and disorder of the particles, so delta S degrees is positive, plus symbol. Analyze the thermodynamic signs for forming solute-solvent interactions. Step 3. Enthalpy. Delta H degrees ion dipole forces are established as water molecules surround the free Na to the power plus and Cl to the power negative ions. Because forming new chemical attractions is a stabilizing process that always releases energy, exothermic, delta H degrees is negative, minus symbol. Entropy, delta S degrees, as water molecules organize themselves into structured hydration shells around the charged cations and anions. They orient their molecular dipoles systematically. This restricts the rotational and translational freedom of these water molecules, which increases local order, decreases disorder. Thus, delta S degrees is negative, minus symbol. Combine the results to select the correct option. Breaking solvent-solvent. Delta H degrees equals plus. Delta S degrees equals plus. Breaking solute-solute. Delta H degrees equals plus. Delta S degrees equals plus. Forming solute-solvent. Delta H degrees equals dash. Delta S degrees equals. This matching set corresponds perfectly to option A. The correct answer is option A. Breaking solvent-solvent interactions. Delta H standard equals plus. Delta S standard equals plus. Breaking solute-solute interactions. Delta H standard equals plus. Delta S standard equals plus. Forming solute-solvent interactions. Delta H standard equals dash. Delta S standard equals dash.